Mankind has evolved through millions of years. Little by little, we became what we are today, very complex beings with many abilities. And we use these abilities to dominate nature, to acquire an astonishing amount of knowledge, and to produce prosperity and good living conditions. Mental abilities have set humans apart from other species in that humans are capable of creating intricate and complex devices that greatly extend their productivity, such as, for example, devices that allow us to travel 100 times faster than our legs would allow us. But human abilities are not limitless. The human brain cannot do multitasking as efficiently as computers. The human brain cannot focus its attention on many things at a time either. Humans sometimes misunderstand and misinterpret things too. How do these limitations affect the crew of an aircraft? The purpose of this video is to offer an insight into the design of modern pilot aircraft interface and how this interface can help the pilot be aware of his situation and take the proper actions. This video also explains the operating principles that are behind the symbols that the pilots see and the displays, and behind the automation whose purpose is to reduce the pilot workload. Early aircraft had very rudimentary instruments, and the flight was basically visual. That is, the pilot used to fly the aircraft by looking out for visual references. Knowing where the aircraft was going, or if it was pointing up or down, or where the wings were level or not, was easy, because it required no mental effort. It was just a matter of looking at the horizon and looking at the ground underneath the aircraft to figure out what the situation was. Flying visually as it was in the beginning, from the point of view of mental effort, was as simple as riding a horse or sailing. However, visual flight is not always possible. One cannot do visual flight at night or with reduced visibility. Those constraints severely restricted the use of aircraft. Additionally, as the aircraft started to have higher performance, the need to look at gauges became inevitable to extend the use of aircraft. Gauges were dials with pointers. Gauges were the only type of pilot aircraft interface the technology available in the 20s and 30s would allow. Looking at gauges means looking at numbers and making sense of them. When we say making sense, we ultimately mean that the pilot has to build a mental model of something, or in other words, that the pilot has to do some interpretation. That was when pilots began doing mental effort, so piloting skills were not the only quality expected from a pilot anymore. And this trend from piloting skills to other mental abilities still continues today. As the technology evolves, less action is required in modern cockpits, but more awareness is needed. What if the aircraft flies into a cloud and the pilot finds himself surrounded by that foggy air where no ground, no horizon, or no sky can be seen? How can he know whether the aircraft is upright or upside down? The pilot cannot rely on his senses. It is well known that we do not have the capability to tell up from down when there are no visual references, and the pilot is subjected to uncommon acceleration. That is when the so-called instrument-based flight came into play. Gyroscopic instruments were created to let the pilot know where the sky is and where the ground is. The idea was to have the pilot watching this instrument and maneuver the aircraft accordingly. But differentiating down from up is not enough. The pilot must make sure the aircraft maintains a safe speed and altitude. And of course, the pilot must steer the aircraft towards where he wants to go. But how can the pilot know where to fly to if he sees nothing? That is when radio navigation was born, and navigation gauges joined in. The resulting fact was, the pilot had to watch several gauges to make sure the aircraft was at the proper altitude, speed, attitude, and direction of flight. As we mentioned before, paying attention to several things at the same time is something difficult to human beings. To overcome this difficulty, extensive training became necessary. Pilots had to learn to move their eyes from gauge to gauge and combine everything he sees in a mental model of what the status of the flight is. This scanning technique was a challenge. It required a lot of effort and attention. Any distraction could end up in spatial disorientation and a resulting upset. And pilots had to fly monitoring the clock and doing geometrical calculations to estimate distances and relative positions. Slowly, improvements started to appear. The instruments were arranged in a standard T-shaped layout where the 4 basic instruments show the essentials of the flight status. At the top part of the T there were the airspeed indicator, the attitude indicator, could also be a turn and bank indicator, and the altimeter. And under the attitude indicator, or turn and bank indicator, there was a navigation instrument showing the horizontal navigation status of the aircraft. New improvements slowly made instrument-based flying safer. Improvements such as the moving background attitude indicator that clearly indicated where the ground and where the sky are, by making them respectively brown and blue. The addition of the HSI, the horizontal situation indicator, and the appearance of automatic pilots with acceptable performance. The first flight directors were a quantum improvement in the pilot-aircraft interface. And the reason for that is the fact that the flight director directly tells the pilot what to do with the flight controls. It turns the pilot into a human autopilot, since basically the signal that drives the flight director is the same that would drive the autopilot servos, if properly amplified. The flight director synthesized what to do laterally and longitudinally in a single symbol. It is always better to have the interface directly tell the pilot what to do, because that frees the pilot from the task of interpreting. There were 2 types of flight director symbologies, cross pointers and V-bars. The first had the advantage of segregating lateral and longitudinal guidance in different indications. So if one of them was unavailable, you could still use the other one, but the V-bar was perceived by many as more intuitive. Another quantum improvement in the pilot-aircraft interface was the introduction of electronic displays. The early electromechanical instruments did not allow much flexibility. But these new displays, when associated with software, allowed all the flexibility of the world. One could change the indication on the fly according to the flight situation. One could use flight phase-based inhibition, and one could show anything to the pilot. Just because anything could be shown to the pilot with these new displays, a new paradigm went into force. Showing as much information as possible to the pilot had to be avoided. Pilots cannot deal simultaneously with massive amounts of information. Excess information is as bad as lack of information. So the new paradigm became not to overwhelm the pilot with information he cannot cope with. Aviation is big business. Airline companies need to make money with their aircraft. So, throughout the last decades, several technological improvements allowed precision instrument-based approaches coupled to the autopilot. New devices to alert the pilot that the ground is close or is closing in fast, and many others. But there was still something missing. The awareness about which direction the aircraft is flying to and what the energy situation is. We will try to explain these points.